In 2.8, we're going to be looking at graphs of quadratic functions. More specifically, we also call them parabolas. Sometimes if you really go East Texan with it, looks like a parabola. It kind of looks like a bowl shape or a U shape when you're looking at them. So we've gone in depth with linear functions. We've looked at intercepts and we've looked at x and y intercepts. We've looked at slope. We've looked at where they can be increasing, decreasing, etc. So for this lesson, we're going to go just more in depth with what can we see graphically from a quadratic function. So there are certain characteristics that we did not have when we looked at linear functions. There's some new vocabulary as we go. So definitely I would take notes of the shape and this first figure here. When we have a parabola shape or a quadratic function, they all have this U shape. Therefore, they all have something known as this axis of symmetry. It's this imaginary line that cuts the two in half. I always think of like a grade school snowflake when you can fold a piece of paper in half and cut it and then you open it up and it's perfectly symmetrical over that fold that you make. And so this axis of symmetry is not a physical line that you will draw. It is more of a dotted line that we just put on there to say, hey, here's where the middle of this function is. Also, in regard to the axis of symmetry, on that axis is where you have something called the vertex. This is also the maximum or minimum value of the entire quadratic. You can see in this case it is the lowest on the graph it'll go. So we will have to have this conversation as we go forward with our domain and range and then talking about range. Other two words that are familiar to you, so not new vocabulary, are x-intercepts. You'll notice that in this function I have two x-intercepts. With a quadratic, we could have two x-intercepts. We could have one. We could also have maybe 0, especially if this graph was maybe moved up here into this quadrant and it was above where that vertex is. And the last thing we have is a y-intercept. Now the y-intercepts are going to vary. You might have 1, but you're probably not going to have 2 or 0 because if this graph does get larger and larger as it goes up. So we have something of our y-intercept. You'll also notice that when we graph this, you're going to have to use the different shape tool as you're plotting those points. So all this being said, I just want to kind of visually show you a quadratic on a graph and point out to where these are, but we are going to have a very detailed and specific way and formulas on how to find all this information because it's not going to be all as straightforward as a vertex right on 1 or an intercept right on -1, etc. So we're going to have two sets of formulas. First of all, we need to talk about the standard form for a quadratic. The standard form for a quadratic is f of x equals ax minus h squared plus k. This is really important when it's set up into this form because we can grab information very quickly and easily. A couple information that we can figure out is the axis of symmetry will be at x equal to h. Remember with our transformation unit, we talked about how this part moves you left and right. So it makes sense that if I take my parent function and I move it left and right, that would affect my axis of symmetry. So axis of symmetry is an equation of x equals h. If you just put h, your homework and the exam, that will be marked incorrect because it has to be an equation. It is an equation of a vertical line, so that's why we have that x equals there. Next, the vertex. Your vertex is always on your axis of symmetry, and so your h value is going to go for its x coordinate, and then in order to find our y coordinate, it's the movement of it up or down, so that'll be your k. So this is a really nice form because you can pull information very quickly out of this form. It's not always in this form. You could do completing of the square or something like that to go into this form. But a more direct approach is if you're given the general form of quadratic, which we're used to seeing. We saw this in a previous unit when we were working with quadratic formula. If it's in this ax squared plus bx plus c form, then you're going to have to use a formula. You'll notice axis of symmetry again is x equals, it's an equation of a vertical line, negative b over 2a. And remember quadratic formula? This was a little piece of your quadratic formula, so that makes sense that we see it here. Once we get our x value, we're going to take our x value, plug it back into our original to find our y value. So you'll notice for our vertex formula, x equals negative b over 2a is my x. And f of that, meaning take your x value, plug in your original, would be your y. So as we go throughout this lesson, you're going to see us using both of these as we go forward and ask and answer questions about them. Very simple test questions could be, what is the axis of symmetry in this form? You just go x equals whatever that h value. Or what is the axis of symmetry in this form? X equals negative b over 2a. Other questions that could be asked is, what is the vertex? What is the vertex? Just given both of these forms. Just making sure you understand how to work these 4 pieces of information. So moving forward, you're going to see us use those as we go. But to kind of ease into this, let's just look at this first example here. And it says, determine the vertex, the axis of symmetry, zeros, and the y-intercept of the parabola. With this one, if it's not too bad on our coordinate plane, we could probably just do this without the formulas because we actually don't even know the equation of this line. They just gave us a graph. So first thing I want to do is I'm going to determine the vertex. Remember, the vertex is the lowest or highest point on the graph. It's right here where we go from decreasing up to increasing or vice versa. So my vertex would be at 3, 1. Then it says, what is the axis of symmetry? Well, remember, this axis of symmetry is a vertical line that runs through the vertex. So our axis of symmetry, we can see from the graph here, is going to be at x equals 3. Remember, it's always x equals your value because it is an equation of a vertical line. So I've got the vertex, I've got axis of symmetry. Now we need to find the zeros. The zeros, let's just kind of make a note here. This is going to be your x-intercepts. They're also called roots or solutions. And so you're going to see kind of some different wording as you go about, but we're all referring to our x-intercepts. Now in this case, this is what I talked about on the previous page. There is no x-intercepts. They're never ever going to cross this x-axis. So in relation to x-intercepts, or the verbiage they use with zeros, there is none. And that's okay. Then the last one is your y-intercept. So notice where your graph is crossing your y-axis. You can see it's crossing here. So this would be at the point 0, 7. And this would be your y-intercept. And they just wanted you to be able to identify where all this information was, so similar to what we were kind of looking at that picture on the top of the first page. Okay, next one, we're going to go a little bit more in depth with our vertex and whatnot. It says find the vertex of the quadratic function. So when you're looking at this quadratic function, you'll notice that this is in the form ax squared plus bx plus c. So the first thing you want to do is you want to identify your a, b's, and c's. A is 2, b is negative 6, c is 7. Make sure you maintain that negative with the 6. You'll notice when we do a, b's, and c's, it's just the coefficients in front of the variables. It does not include x squared or x. Just like what we were doing with quadratic formula, we would identify our a, b's, and c's. Now I'm looking for the vertex. So the formula that I want to use for this is x equals negative b over 2a. I've already identified my a, b's, and c's, so I'm going to say this is going to be equal to negative from the formula over 2 times a. B is negative 6, so we do have 2 negatives there, don't lose one. 2 times a is 2. So this gives me 6 over 4, which reduces to 3 halves. You always want to reduce your fractions down to lowest terms. So in regard to vertex, I'm looking for an xy value, so 3 halves is going to be my x. In any case where you're given one letter and you're looking for the other, you're just going to plug back into the original. So I'm going to say f of 3 halves. That's equal to 2 times 3 halves squared minus 6 times 3 halves plus 7. Just use your scientific calculator and I would just plug all that in. Be careful that you always put your fractions in parentheses so that they get squared and multiplied correctly. And this comes out to be 5 over 2 or 2.5. Improper fractions are the best form to leave your answers in. So this gives me a y value of 5 halves. Now bonus, if they had asked you for the axis of symmetry, we could easily answer that as well. We've already done all this work. It would be at x equals 3 halves. And so find the vertex of the quadratic function. F of x equals 2x squared minus 6x plus 7. Here's my vertex. And we're not going to rewrite this one into standard form. But I wanted to show you how this formula works out with your numbers. It's okay to have fractions. Just go slow and use your calculator to help you along the way, especially when plugging that value back into the original. Now, part 2, let's just kind of have a review of domain and range. We spent a whole section on domain and range, and we looked at all the different parent functions and what their domain and ranges would be. And so if you remember, the parent function, just y equals x squared, it had a domain of negative infinity to infinity. You can see from the graph of that parent function that it's going to get wider and wider and wider, so there's no x values we're not going to use. And then we talked about the range being from right here where it starts, so 0, and we're going to include 0, to positive infinity. So if you understand what's going on with your parent function, again, back from Unit 1 of domain and range, then you'll understand what's going on as we move things around. So say I have something in the form y equals ax squared plus bx plus c. So related to our parent function, well, our domain is still going to be negative infinity to infinity. That's not going to change. Whether we move it left and right, it's still all the real numbers. But what is going to change is going to be in relation to our range. And a couple of things to remember with that. Since we've done parent functions, we've also talked about transformations on functions. And remember when it was in this form, go back to my standard form here, that this a in front here, if it's negative, it could cause a reflection. Thus, it would point a downward shaped graph. We're going to have that come into play. And then also, so that's going to flip your range. That would flip it down, and then your vertex would be your top of your point. We'd be looking at negative infinity, and we'll do one like that in just a minute. But what's going to happen is your vertex is going to decide either your starting or your stopping point. So you can notice here, this was the h value of my vertex. It was at 0, so that was my starting point of my range. So we're going to take all of this into effect. We're going to have to consider where the vertex of a parabola is lying, and then we can determine what the range would be. Again, it's going to be based on the vertex. So let's look at this next problem and see if we can kind of put all the pieces together. So it says find the domain and range of f of x equal to negative 5x squared plus 9x minus 1. So first of all, the domain for any of these quadratic functions in interval notation is going to be from negative infinity to positive infinity. But we're going to have to look at, is this being reflected and where the vertex is in order to figure out the range. So you'll notice here that this negative being in front here causes a reflection. So this thing is going to be pointing downward. So that means it's going to go from negative infinity to whatever my vertex is, so some h right here. So my range, I'm going to have to find my vertex. And I'm going to have to find the y value of that vertex. So I start with my x, so negative b over 2a. Let's see, a is negative 5, b is 9, c is negative 1. So it would be negative 9 over 2 times negative 5 gives me negative 9 over negative 10, so 9 over 10. Now that's just where it's placed left to right. I have to do f of 9/10 in order to figure out the highest y value. So it'd be negative 5, 9 over 10 squared, plus 9 times 9 over 10, minus 1. And this comes out to be 61 over 20. I just used my calculator to input all this using parentheses where necessary, and it outputted about 3.05. But the improper fraction would be 61 over 20. So finding the domain and range does go back to what you were doing in previous sections with domain and range, but it also is going to take into the fact of transformations and vertex and kind of putting all three of those concepts together. So the answer is not difficult, but you got to remember the pieces of the reflection and the vertex to help you with that range value. So that leads us into just kind of part 3, more characteristics of a graph. We just talked about this. So if our a is greater than 1, it's going to open upward, meaning we do have a positive a. If our a is less than 1, and these should be 0, excuse me. If a is greater than 0, it's going to open upward, meaning it's a positive. And so it's going to go something like this. But if A is less than 0, meaning it is a negative causing a reflection looking something like this, it's going to open downward. And there are going to be some questions. We'll do one here in a minute. And it will say, which way is it opening, upward or downward? That's going to help you with your range and also with your graphing. A couple of other characteristics of a graph. Remember, when you're looking for your x-intercepts, you're going to set your y equal to 0 and solve for x. And you have the possibility of 0, 1, or 2 answers. You saw from a previous example, we got a case of 0. You've seen in other solving of quadratics, we get 2 or 1 answers, so just be aware of that. Then looking at y-intercepts, you reverse that and you say, let's set x equal to 0 and solve for y. We've been doing this for quite a bit in this course, so hopefully you're becoming way more familiar with your y-intercepts. And so let's just kind of put some of all these concepts together. Here's an example. It says, consider the parabola given by the function f of x equals 4x squared plus 8x minus 1. Answer the following for this parabola. The graph of this function opens, so that means I'm going to have to look at my a value. You can see that it's greater than 0, so it's positive, so it's going to be opening upward. Give the domain of the function, use an interval notation. Well, it's a quadratic, so it's going to be like the parent function. It's going to go from negative infinity to positive infinity. And then it says give the range. Remember with the range, we need to consider it's facing upward. So that's going to go from our vertex to positive infinity. And then we now consider where that vertex is. So if we look at where the vertex is, we would have to say, okay, it's in that general form here. So let's see, A is 4, B is 8, C is negative 1. So I'm do my equation for vertex, so it's negative B over 2A. So it'd be negative 8 over 2 times 4. So it'd be negative 8 over 8, which is negative 1. Now I need a y value because that's what range is dealing with. So I'm going to have to take negative 1 and plug it back into my function. F of negative 1 equals 4 times negative 1 squared plus 8 times negative 1 minus 1. I just use my calculator to help output this, negative value of negative 5. So it tells me my vertex is at negative 1, negative 5. So in regards to range, it's going to start at negative 5 and go to positive infinity because it is one that is pointing upward. So you can see the bottom of it is the y value of my vertex to positive infinity. So in all that being said, let's kind of review some of the transformations that can occur and just kind of remember our standard form here of a x minus h plus k. Now remember, the h is going to move you left and right, and it's the opposite of what you think. The k is going to move you up and down, and is exactly what you think. The a is going to do your stretch / shrink. And remember, it's important to know that it's changing the width, but you do not have to know the specifics of vertical stretch, vertical shrink, etc. And if there was a negative to be had right here, then we would have a reflection. All of this will be on your upcoming exam. Determine the equation of the graph of f of x equals x squared that has been shifted up 4 units. I know that outside of the square, the plus k is what shifts me up, so I'm going to say that would be g of x equal to x squared plus 4. Also determine the equation for the graph of f of x equals x squared that has been shifted down 4 units. So I would say that would be x squared minus 4. So it just has you creating equations of lines based off what you remember about your transformations. And so I want to kind of do this review up here from this. Next one says, determine the equation of the graph of f of x equals x squared that's been shifted right 2 units. Now remember, when you're working with your left and right, it is the inside here, and it's the opposite of what you think. So it's going to be x right would be minus 2 squared. It doesn't say anything about a shrink or stretch or a reflection or up and down, so I only have that minus 2 there. And then it says also determine the equation for the graph of f of x equals x squared has been shifted left 2 units. So again, left is going to be on the inside. It's the opposite of what we think, so it's going to be plus 2 squared. So definitely this section brings together all that we've been doing with quadratics with parent functions, domain and range, and transformations, and really kind of ties it all together. Determine the equation for the graph of f of x equal to x squared that has been compressed vertically by a factor of 1/2. Well, remember, in that form that we just talked about here, this a value is what's going to be affecting that. And so that means I would just need to place that multiplier in front of my x squared, so I could say this is 1/2 x squared. Also determine the equation of the graph x squared that has been vertically stretched by a factor of 3. So that means this would be equal to 3x squared. So I want to do these 3 examples so you can see just the small pieces of how all these different transformations and changes and where they occur. So now let's kind of put them all together, and here's some practice problems. Write the equation in any form for the quadratic graph below. Okay, so I like to go to my standard form ax minus h squared plus k because it clearly states a vertex and a point. So if I can find those 2 pieces of information, I can solve for a and then rewrite this problem. So my vertex is going to be here at this point, so I'm going to say my vertex is at the point -1, 0, so that's going to be my h and k. And then you just want to find another good point on the graph. And when you're looking at another good point on the graph, I'm talking about kind of where it goes through the crosshairs. Like this one would not be very good. This one would be good. This one would be good. This one would be good. Any of those 3 would work out. I'm going to use this one right here so I can just kind of play with 1s and 0s. So this would be at the point 0, 1. And then that would be my x and y. So I'm going to use these 2 points in order to help me figure this out. So I'm going to say 1 equals a x is 0 minus h, which is -1, squared plus 0. This minus is from the formula. This is the negative from the 1. Be careful with that. 1 equals a, let's see, -1 is 1 squared plus 0. So just 1 equal to 1a and divide. So I get a to be 1. That is not always the case. It just happened to be with this one because we didn't have any change in width. So then rewrite it with your a, h, and k all filled in. So y would be equal to 1 x minus -1, so plus 1, squared plus 0. And really best form would just be to say x plus 1 squared. Multiplying by 1 doesn't change anything. Adding 0 doesn't change anything. And that would be my final answer. Lastly, part B, it says match the function with its graph. So with this one, they already have them graphed, so I'm going to use my different transformations to help me out with this. First of all, you'll notice that my a value is positive, so that means it's going to be facing upward, and so it's not going to be these 2 graphs because they're both facing downward, which would be a reflection, so I'd have to have a -1 there. Next, I'm going to notice that I need a shift downward of 4 units. You can see this one went down, this one went down. Again, these didn't. And then I need a shift of 1 unit, opposite of what I think, so I actually need it to go to the left. And so notice from the origin, I'd have to go down 4 and to the left 1. This one I went down 4, and this one went to the right 1. So this would be the correct graph for this function. So it definitely helps you to analyze and put all this information together. The next part of that one just asks where the axis of symmetry is. And notice it would be right here where that vertex is. So it has an axis of symmetry at x equals -1. You can also pull that from your function up here. This is like x minus -1, so h is -1. Last example, and we'll be done with this lesson. Consider the quadratic function. It wants us to find the vertex, the axis of symmetry, the intercepts, and so let's just kind of start with it. First of all, in order to find the vertex, I'm going to have to use my formula. So first I'm going to identify my a, b's, and c's. A is 1, b is -4, c is 3. Then I'm going to do x equals -b over 2a in order to find that vertex. So that would be equal to negative of -4 over 2 times 1, which reduces down to +2. So that would be the x value of my vertex. In order to find my y value, I'm going to have to say f of 2. So it would be 2 squared minus 4 times 2 plus 3. This gives me a value of -1. So -1 would be my y-axis, would be my y point. The equation of the line of symmetry is just going to be at x equals 2. Remember, this is an equation. You can't just put a 2 there. The vertical intercept is going to be my y-intercept. So in order to find my y-intercept, I set x equal to 0. So I get 0 squared minus 4 times 0 plus 3. So I just get 3. And it says it's a point. So I'm going to say 0, 3. 0 is what I plugged in for my x. 3 is what I got out of it. My horizontal intercepts are going to be my x-intercepts. And it says, is R the point to separate multiple answers with a comma. So I am going to have to use a comma, and I'm going to have points. So I'm going to set my y equal to 0 and solve. So I'm going to have to go back to my factoring skills. This will be x and x. The back sign says they're going to be the same sign. They're both negative. Think what will multiply to give me +3 and add to give me -4. That would be 1 and 3. And then solve that. So x is 1, x is 3. But it says they're points. And so I'm going to have to say 1, 0, separate multiple answers with a comma, 3, 0. So our last question in this lesson just kind of pulls everything together that we've been working with. So I hope this helps as you navigate through section 2.8. If you have any questions along the way, feel free to contact me and I'll be happy to help you with any additional resources or help on homework as you get to it.